put my next section flag up here so that I remember that this is where I want to cut. And now we'll move on to classes part 2, lecture 19. All right. So for lecture 2, what we're going to do is we're going to kind of continue our discussion of classes, and we're going to do this in the context of looking at our Yelp data by providing what we're going to call a restaurant class. And I think the Yelp data actually has non-restaurants in it, but that's okay. We're going to pretend, and we will just generate a restaurant class that allows us to take that big realm, that big ream of data, and instead of having a list of lists where we have to know what index is the latitude and what index is the longitude, what we're going to do is we're going to provide methods that allow us to pull that out much more intuitively and much more easily. So we can start off by looking at our Point2D class, just to kind of there's Spider. Okay, we can look at our Point2D class just to kind of realign ourselves with where we were, right? And what we should see in our 2D class, and I'm just pulling up my notes so that I see what I'm supposed to show you, just so I don't forget anything. Well, we want to see a couple of things. The first thing is we got to remember that we have this, right? This is how we define a class. Keyword class, name of the class. We derive from something, in this case, an object. Almost always, at least in this class, always, you'll be deriving from object. And then there's a colon, and then we have a sequence of methods, and we could actually have attributes in here as well. But what we're going to want you to do from a coding style perspective is we're going to want you to define this initialization block, and we're going to want you to do your initialization of all your attributes within the initialization block. So for the Point2D class, we have 2 attributes. We have an X coordinate and a Y coordinate, and we're going to initialize those to our values X0 and Y0. And if either X0 or Y0 are missing, the default value for them is going to be a 0. Okay? And you want to put these here because now every Point2D class is going to have this information along with it, no matter whether the person forgot to add a Y coordinate or not. It's actually there, and you can actually use it. Remember that this initialization function, the 2 underscores there, the keyword init, and then underscore underscore. This is the function that gets called whenever you do something like R equals Point2D 357, and I think that needs to be an equals instead of a minus, right? When you do that, that calls this code to set up your X and Y attributes. After that, and notice this for all of the methods, all of the functions that are in this, the first argument is self. The self refers to the current object. So if we want to do something like r.magnitude, what is the magnitude of r? How far is it from the origin? And why can't we spell? Right? You notice there are no parameters there, no arguments there, but there is one parameter here. This parameter is the actual object itself. And all of our methods are going to have this self as its first parameter, right? Even when we're going to do something like compare 2 parameters with the dominates function, or we're going to scale a parameter by a constant, the first parameter is always going to be the object itself, you know, r in this case, and then any other parameters can actually follow. Functions that are in a class are generally referred to as methods, at least in Python. They can print, just like any function can do. They can return values, just like any function can do. But they also have the opportunity to change the attributes by using this self dot notation. So when you see self dot equals something, that's actually changing one of the attributes for the function to have a different value. We have a lot of these functions that have underscore underscore, and these are, you can define anything with an underscore. I can do something like def really dumb function underscore num minus 124, right? Underscores are allowed characters in function names. So this is allowed to be whatever you want it to be. The key is that this is a flag that says that this is something special in Python. So avoid using these unless you're actually defining that something special. So, for example, string or r.string, for example. Oops. String R actually calls our function r.string with the underscores. Okay, and the job of this function, this underscore string, is to return the representation we want for R when we print it out. Essentially, that's a good way to think of it. So if we want R to look like this when we print it out, we write our underscore string function that returns a string, right? This is not a print statement. This is actually a return on a string that gives us the format we want when we actually print the string. So if we do print R, and then if you just do print R, by the way, that calls string R implicitly. Okay? So underscore something underscore has special meanings. The string function takes the value and converts it to a string for printing, essentially, or for looking at. Underscore equals tests for equality, right? Takes two parameters, the current value R, another value O, and it returns true if the two objects are equals by the measure we want to do. Multiply takes, again, maps into, okay, so the equality function maps into double equals, right? The multiplication function maps into the asterisk, right? Subtraction maps into underscore sub maps into subtraction, right? Underscore LT underscore maps into the less than symbol, underscore LE underscore less than or equal to, right? So all of these are functions that map into operators. They all have this special notation. The special notation allows us to define things that work with the operators we may want to work with, like plus, minus, star, slash, etc. All right? Okay. This is a pretty confusing part, so I want to make sure that we kind of cover that as well as we can. All right, so now we have the basics, right? So let's start working on our next little adventure. If you think all the way to the Wayback Machine on our Lab 5 with the Yelp data, we had data from Yelp. And what we would have is we would have something that looks somewhat like this. And in fact, I think this would be a line from the file. We can actually look at that here. right? And what we had was we had a sequence of lines of the file, and each one had a restaurant name, and then a bar, and then the latitude, and then a bar, and then the longitude, and then a vertical bar, and then an address. And the address had these embedded plus signs that delimited different lines of the address. So this would be 407 River Street, Troy, New York, 12180. And then it had a URL, which was, you know, the website of the place. It had the type of establishment it was. This in particular is a bar. And then after that, it had 0 or more reviews, where the reviews were customers saying, yes, I liked it, or no, I didn't like it. And when we were doing this, I don't know about you, but I found this to be a headache trying to remember that once I've parsed it out and broken it up based on these little vertical bars, you know, put it in a list, maybe a restaurant list instead of a restaurant class. And I had to know that Mecca's Lounge was at index 0, the latitude was at 1, the longitude was at 2, the address was at 3, you know, the URL was at 4, and you had to kind of keep this in mind, and you had to explicitly reference those every time through. What we're going to do now is we're going to look at building a restaurant class that, instead of saving each one of these records, each one of these Yelp evaluations of the business, instead of saving that as a list of fields, it's going to save it as actually a class. And the class is going to provide easier methods that will allow us to actually pull out those fields and use those fields and do other things as well. So let's see. If you go to the Lecture19 zip file in course materials, trust me, it's there. That's where I got this data from. You can pull up a file called Lecture19 restaurant exercise.py. And this is what we're going to use to get started with. And you'll notice that this isn't the restaurant class. It uses the restaurant class. So from the restaurant class is going to be stored in a file restaurant.py. But before we start developing the restaurant class, we want to figure out exactly what it is we want to do with the restaurant class. What methods, you know, what APIs, how do we want to access it, and what data do we need to get out of it? And for some reason, my other computer keeps shutting down, so I lose my notes when I'm not actually on my notes page. So I'm going to start off by going to the bottom of this file, right? And here's where we have our little guard that says if name equals main. So in other words, if we're running this, we want to open up a restaurant file, and then we're going to want to go through and we're going to want to build up a list of all of our references. Now, the difference this time is, instead of building up a list of lists, right, a list of records, what we're going to do is we're going to build up a list of class objects, a list of, you know, instantiations, a list of actual occurrences of our class restaurant. And then once we do that, maybe we want to do some other things. And here's some things that might be possible. For one, maybe we just want to print out some restaurants. We want to look at, you know, either selecting one or more, or searching for one, but we want to be able to print them out and look at what information we have on each restaurant. So we're going to need to write, so that means whatever form we put our data in, we're going to want to write this string function. Come down here, maybe we want to find out what restaurants are in a specific city, and you'll see that all of this is commented out, and it's commented out so that we can actually do our development while we're, you know, we can use this after we get the development in, right? So we can look through here and we can see, you know, maybe we want to figure out restaurants in Troy, New York, for example. Maybe we want to find out what the average review is for the restaurant. And maybe we want to find out which is the best rated restaurant in the area. You know, those are two good things we might want to do, and that kind of guides us along what we're going to have to be able, once we know how we want to use this, we can kind of start figuring out what methods we're going to have and what attribute data we're going to want to look at. Okay, so let's go back now and let's look at this line. There's a whole lot encapsulated in that line. This is where we're going to actually build up our list of restaurants. Once we do, then we have the ability to go through and search through, to print them out, or go through and search through them and do other things. But the first thing we want to do is build a list of restaurants, and we have a function there called build restaurant list. So, all that does is we take a restaurant list. We have to be able to read it from a file, or we take a file name, and then we start off by making an empty list. We walk through every line of the file, and every time through, we grab the next restaurant in terms of a member of the class restaurants, and we put it on our list. So this is pretty simple. It doesn't need much. We haven't really gotten through anything yet. Let's see what convert input to restaurant does. Here's where we're actually doing most of the work for this entire file. This parses our Yelp data. This is that nasty word parse again. Parse just means taking string data and turning it into what it's supposed to mean, right? So let's look at what we do here. Well, the first thing we do is we read a line in, we strip it, and we split it at our field separator, which is the vertical bar, right? For this part of the code, we actually have to know where everything is located. But the nice thing is this is pretty isolated. Once we get past this point, once we've built, we need to know this in order to provide it to the restaurant class. But once we've done that, we never have to know that again. So we have to know that the name's in the first field. We have to know that the latitude is in the second field, the longitude is in the third field. And remember that when I say this is 0, this is the first field, it starts with 0. So the field at index 0 is the name. The field at index 1 is the latitude. At index 2 is the longitude. The address is the field at the address is in field 3, and in this case, if we split that, we actually can store an address as a list of strings broken up into the lines of the address by the plus character. So we're basically pulling out a string here, a float here, a float here, a list of strings here, a string here for the URL, a string here for the restaurant type. And then for the reviews, what we do is we start at field 6, the first possible review. We walk through the end, and we calculate a list of integers. So this is a list of strings for the address. This is a list of integers for the reviews. And once we have those, we're just going to simply call our restaurant, right? This is how you call the initializer for the restaurant class, right? We have from restaurant import restaurant. This is how we call the initializer for the restaurant class. And then we're just going to give it that data we parsed out, and it's going to create our instance of the class for us and return it back, which goes to our build restaurant list, which appends it on to the end of the current list of restaurants, right? So this is going to go through and call convert input to restaurant for every line in the file. This will return a restaurant object, and that restaurant object is going to be thrown onto this list of restaurants. So at the end of coming through build restaurants, we're going to have a list of objects of the class restaurant that we can then go through and do all this other cool stuff. Well, if we want to look at this so far, just for the non-commented out code, what do we need? Well, we need this, right? Our restaurant class needs to provide an initializer, and our restaurant code needs to provide a string function, right? That's all that's really in here that references the restaurant class from the non-commented out code. And then if we look at the commented out code, well, right here, we're looking for a function isInCity that takes a city name and tells us if the current restaurant is in that city name. So this is going to return a Boolean. So we need a Boolean, a method isInCity that takes a city name and returns a Boolean if the restaurant R is in that city. And here's another one. We're asking for the average review. So we know that we're creating up here in our convert input to restaurant, we're converting our reviews into a list of reviews. So we have a list here. We need the average. Okay, we can get between a list and the average. And then we need the ability to access the name of the restaurant. You can see that this is actually accessing the attribute directly, which I told you we don't in general want to do. We'd prefer to use what they call a getter implementation. And really that's all, right? Average review, name, isInCity, a string function so we can print it out and look at it pretty, and this initializer. And if we have that, once we have all that data, we have the ability to actually implement our once we have all of these methods in our restaurant class, and we have all the data we need to generate these methods in our restaurant class, then we're set to actually go and run this code and ask the questions we want to ask. Okay, so that's kind of the functionality we need. And now we can start thinking about trade-offs between methods and attributes. One of the things we looked at, if we look at the code we already had, for the address class, we're actually keeping a list of strings. And those lists of strings are, splitting the address class at the plus symbol. We can keep it that way. We can convert it to a different form if we'd like. But it kind of makes sense to have, to take that address string and only break it up once, right? Let's not keep breaking that up. How many times do we have to put it back together again with a plus sign? And if we do have to put it back together again, well, we can always do that with the join. So, we can pretty much live with the attribute for the address being a list of strings. Same with the reviews. We have two options. The only thing we need in the code we just looked at was the average review, but there's possibilities that we might want to mess around with the average review. I think we dropped some before, or at least you will in homework 7. So, maybe we want to keep all the reviews. Maybe that extra data we want, the extra data on all the distribution of reviews. Maybe we want to calculate things other than average, like the standard deviation, different types of data on the reviews. So keeping actually a list of reviews is probably important as well. We do have this latitude and longitude. And well, really, latitude and longitude is actually kind of a 2D point. So maybe we want to actually consider using our Point2D class to actually hold our latitude and longitude. The point is at this time we've looked through, we've kind of considered at least one case of how we might want to use this class, and we've gone through and kind of built ourselves a little roadmap for what we need to do next. So let's look at the restaurant class now.